Hello everyone, I'm Xiao Gang. In the last lesson, we added a piece of code similar to frame rate control. What are we going to do in this lesson? In this lesson, we will mainly talk about the inner loop, how we can further improve this framework, because now the outer loop is well controlled, but we haven't implemented the inner loop yet. So what is this inner loop? We can show you the code we have already written. The written code is located here. Then let's first talk about our overall design approach. That is, we must make good use of this MVC, or MVC-like concept. That is, the UI is just the skin, and then the underlying interface, the underlying functionality is C++ code. This is our bone. Then we have a middle layer in between. That is our transfer layer. It is the flesh. It is equivalent to skin, flesh, and bone. So the flesh is in the middle. It acts as a layer connecting the upper and lower parts. Then, on the surface, this P, this UI. That is the interface used by the user for clicking. And this core is where we actually execute the logic. Based on this matter, we designed this small program called Slate. So obviously in this place, it is our UI. S stands for Slate. This is how our UI is written. And in the original code of this UI, no logic is allowed to be written. Just like when you write in UMG. We should try not to write anything in the two-point logic of UMG. We only bind slots on UMG. This is a very good practice. You can see that when we implement this code, we bind this slot here, but then here, this place doesn't have it. Here we also wrote the logic into our UI layer, written onto this piece. This is, but it's easier to write, easier to demonstrate. I'll stop here. So this count code, what is this? It actually corresponds to our calculation code. In the functions place, the underlying bone of Slate, that is its underlying interface. It calls this count code thing. And this morpholame rename, this one doesn't have an underlying interface because we wrote all the code on its skin, wrote it on the UI. Okay, so the Slate program code is our role, is our subsystem. Because this is a standalone program, we don't have a subsystem. Subsystem depends on the ng module. We can't use it that way. So we wrote a singleton using the traditional approach as a management class for this entire module. A singleton management class for this functional module. So this is our subsystem. Is our role. Okay, and here there are some util. As for that utility, it actually provides some of our common code. For example, sometimes we have some configuration codes. Or when we need to read some data we recorded last time. In such cases, we wrote a Slate program, a class like util. Okay, that covers the purpose of these classes. This is our log. After writing these things, you have a management class here. This management class, because we didn't bind the delegate, or we didn't bind it to the engine's NAS, provided initialization delegate or a tick proxy or on a structure proxy. So we need to manually tick some methods of this management class ourselves. Manually tick it. Then we come to this place. Here we instantiate our management class. Then after episode 16, execute initialization. Then next, here, we take our old management class and simply tick it. Then after ticking, when we exit, obviously we also need to make it execute and exit. We didn't write it here, but it probably won't matter. If this is okay and normal, before allowing the exit, we need to have our own management class. Perform a simple exit. Okay, next we will reorganize this structure again. So first we come to this. You can notice that here there is only provide. This is very normal. Because this thing will not be included by an external program. Since it itself is a program, it is a project. We generally do not nest projects within a project. One project generally does not reference another project. That's the case. So here it only has provide. Just make it all private. This is fine. Then next, let's create our core, let's call it, and also our log. And our Slate. And our YouTube. Okay. Then next, let's create the corresponding files. I'll just create them all at once. So when we write later, we won't need to go through the creation process again. We'll just write the code directly. So obviously this is where we calculate the code line count. We give it a count code.h. Okay, This part should be 28. Okay, this ish, okay, side p. Then we write the entire core of this. So this core should be guard. We better all add an xg, right? Xg simple. Add a simple, because I'm afraid it might conflict with something else. That would be quite troublesome. This name seems a bit too long. Let's just call it SSP version. This is too long. Not good. If we write it like this, there is an identifier. Okay, this is our core module. Okay, this is the underlying interface, the core module. Right, then let's move on to the log. For the log, we can write the full name. It doesn't matter. Well, let's call it log xdsl8p2g program.h. Then let's take a look at the log here. We'll just write one log entry. Next is Slate. Well, for Slate, we need to write it like this. Slate must start with an S. X wants to counter SSP. We call it count. Count, code, inbox. This part is a bit repetitive, but there's no way around it. This standalone program still guides everyone step by step to create it. This way it will be more complete. Let's change this name to, this is the release of our calculation code. Then let's write another one. Modify line such a release. Okay. Good. Next, let's write this YouTube. Actually, you could also write some red, but we won't write red, because this red sometimes increases our learning difficulty and learning costs. Okay, good. So we have created these corresponding files for us. We haven't written anything yet, right? Now let's refresh the project. Let's directly refresh the engine. To be precise, do a master's degree. Refresh the engine. Let's wait patiently. Okay, let's just override it like this. Okay, we've already overridden it here. So let's do it step by step. So first of all, the first step is definitely to move our log over. Here we include it under our own directory. Okay, then we directly take this static log. Well, we just put it here because we use it elsewhere, and for this log, we add the header file to it. I won't write the copyright comment for this file, just here. Okay, so this log is done. Okay, let's compile it now to avoid any issues before we actually write the code. Okay, the compilation passed, so obviously we need to initialize all these things here. First, add the pound _p once to all header files. Add pound back proberg once here too. Then add pound bar g once to these classes, and this YouTube as well. Next, we include its header file in this CPP. This is where errors are prone to occur. That is, I often make mistakes in these places. When you paste it, you might actually paste the header file in the wrong place, and then you troubleshoot. That is, you paste this from this place to that place. and you haven't changed its name. Then you will make some mistakes here. It is obviously missing. It should be this name. Okay. Then we put this. Then paste it into this CPP file. Okay. Then like this. We need to handle this as well. Good. Now our development environment is ready. Then similarly, this column. We also need to handle it. This one is the most error prone. If you paste it incorrectly, when compiling, you will find its source file includes another one. That is, it includes the wrong one. It can't find it. Let's compile it first. Make sure everything is okay on our end. Okay, alright. So we'll end this lesson here. We have set up the entire architecture of our inner loop for everyone. We haven't started writing the code yet. And we'll also explain to everyone how this architecture works. This is our underlying C++ interface. This is our upper level UI blueprint. This part is our log. And we have some common tools. Please don't hesitate to like, subscribe, share, and support the Mingjing and Diane channel.